When we study functions, what we really are studying is the behavior of the functions, and there's certain things that occur that we also find of interest. One of the things that we find of interest is boundedness. Is there a limitation on the y values? Is there a limitation on the range, right? Boundedness is, we could solve it algebraically, but usually it's easier to kind of figure it out, or at least look at the graph. Graphically you could determine it. Is there a restriction on the y value here? Is it bounded from above, I guess is what I'm saying? No. Because this thing looks like it's approaching positive infinity in the y direction. Is it bounded from below? No. Because it looks like it's going on forever towards negative infinity in the y direction. Right? So when we talk about boundedness, what we're talking about are the y values. Is there a limit to the, is there a maximum y value, and or is there a minimum y value? So let's look at this next one. This next one right here, there's no limit to the y value. There's no maximum y value. I cannot say the maximum y value is 10,000 because really y could be 10,001. It could also be 10,002. And so y, as you look from above, approaches positive infinity. But as you look from below, looky here. That is the lowest y value this graph will have. Here's another low value, which is a minimum, a relative minimum. But here, this is the absolute lowest y value is. So if I were to assign a number right here at this point, at the vertex of this little dip here, that would be the lowest y value. I would not have a y value lower than that. So we would say that this particular function is not bounded from above, but definitely bounded from below. There's a boundary on the y value from below. Okay? So now if we move on to this next function, similar thing, bounded from above, at this maximum and at this maximum, I can't go any higher. There isn't a y value higher than those two little bumps in the curve. There isn't one. So it's bounded from above, but if you look, the graph is not bounded from below. Now, if it's bounded from above and from below, as you see in this final one, we just say that it's bounded. Bounded from above and bounded from below. Now, what advantage would that have? Well, if I can define a function as bounded, that means that it will do what? It will both increase and decrease, right? Well, all the functions have that opportunity, but I can determine the increasing and decreasing based on the boundedness, right? I know this function right here is the maximum value, and this is the maximum value, and we'll talk a little bit more as to why these functions are bounded from above and below. But basically, it's not an accident. There's a reason they're bounded from above and bounded from below, and if we study that behavior, it's useful to us. Okay? So when we look at it, were there any questions about that? So this is the formal definition, and I'll just read it to you real quick. This is based on the graphs that we just looked at. Okay? So a function is bounded from below if there is some number b that is less than or equal to every number in the range of s or f. Any such number b is called a lower bound of the function. Let me read that again. A function f is bounded below if there is some number b that is less than or equal to every number in the range. That's the minimum value, b. Everything else is higher than that. Everything else is greater than that. So we say that b is the lower bound of f. Likewise, a function f is bounded from above or bounded above if there is such a number b, capital B, that is greater than or equal to every number in the range of f. Any such number b is called the upper bound of f. It's the maximum y value for f. Then we say that the function f is bounded if it is bounded from above and bounded from below.